An SE cable stripper is a tool specifically designed for removing the outer jacket of SE cable. It has several features that make it the preferred method. Firstly, it has precision blades. These are sharp and durable blades that cleanly cut through the outer jacket without damaging the inner conductors. Secondly, it has adjustable depth. This feature allows you to set the cutting depth to accommodate different cable diameters. Thirdly, it has an ergonomic design. This makes it comfortable to use for extended periods, reducing hand fatigue. Fourthly, it has safety features. These may include a blade guard or locking mechanism for added safety during use. To use an SE cable stripper, firstly, adjust the cutting depth to the outer diameter of the cable. Secondly, insert the cable into the stripper's jaws, aligning the blade with the edge of the jacket. Thirdly, slowly squeeze the handles together until the blade cuts through the jacket. Fourthly, pull the strip jacket off the cable. While there are alternative methods, they are not recommended. A utility knife can be used if you have a steady hand and are careful not to cut into the conductors. A razor blade is similar to a utility knife, but less safe and more prone to damaging the conductors. It is important to always use a sharp blade for clean cuts. Measure the outer diameter of the cable accurately before setting the cutting depth. Practice on scrap cable before using the stripper on an actual installation. It is highly recommended to use an SE cable stripper for efficient and accurate jacket removal. It will save time and reduce the risk of damage to cables. When working with electrical cables, safety is paramount. Always ensure that the power is disconnected before starting any work. Using the correct tools not only makes the job easier, but also significantly reduces the risk of accidents. An SE cable stripper is designed to provide a clean and controlled cut, minimizing the chance of damaging the insulation of the inner conductors, which could lead to short circuits or other electrical hazards. The adjustable depth feature of the SE cable stripper is crucial because SE cables come in various sizes. Setting the correct depth ensures that only the outer jacket is cut, leaving the inner conductors untouched. To accurately set the cutting depth, measure the outer diameter of the SE cable using a caliper or ruler. Refer to the cable manufacturer's specifications to confirm the jacket thickness. Adjust the stripper's depth setting according to this measurement. Most SE cable strippers have a dial or screw that allows for fine adjustments. The ergonomic design of the SE cable stripper is another important aspect. Electrical work can be time-consuming, and using a tool that is comfortable to hold and operate can significantly reduce hand fatigue. Look for strippers with cushioned handles and a balanced weight distribution. Some models also have a ratcheting mechanism that requires less force to squeeze the handles, further reducing strain on your hands. Safety features are essential for any electrical tool. SE cable strippers often include a blade guard that covers the blade when not in use, preventing accidental cuts. A locking mechanism can also be present to keep the stripper closed when stored, ensuring that the blades are protected and cannot cause injury. Before using the SE cable stripper, inspect it for any signs of damage. Check the blades for sharpness and ensure that the adjustable depth mechanism is working correctly. If the blades are dull or damaged, replace them immediately. A dull blade can cause the jacket to tear or shred, making it difficult to remove cleanly and potentially damaging the inner conductors. When inserting the cable into the stripper's jaws, make sure that it is aligned correctly. The blade should be positioned at the point where you want to begin stripping the jacket. Avoid twisting or bending the cable, as this can cause the jacket to tear unevenly. Apply steady and even pressure when squeezing the handles together. Do not force the stripper, as this can damage the blades of the cable. If the jacket is difficult to cut, try adjusting the depth setting slightly or using a different stripper. Once the blade has cut through the jacket, gently pull the strip jacket off the cable. If the jacket is stuck, try rotating the cable slightly while pulling. Avoid using excessive force, as this can damage the inner conductors. After stripping the jacket, inspect the inner conductors for any signs of damage. If you notice any cuts or abrasions, do not use the cable. Damaged conductors can cause short circuits or other electrical hazards. Always dispose of the strip jacket properly. Do not leave it lying around, as it can be a tripping hazard. Cut the jacket into small pieces before discarding it to prevent it from being reused. While alternative methods like utility knives and razor blades can be used to strip SE cable jackets, they are not recommended due to the increased risk of injury and damage to the cable. Utility knives and razor blades require a high degree of skill and precision to use safely. It is easy to slip and cut yourself with a cable, especially when working in tight spaces. The blades of utility knives and razor blades are also more likely to damage the insulation of the inner conductors, which can lead to electrical hazards. If you must use a utility knife or a razor blade to strip SE cable jackets, take extra precautions. Wear gloves and eye protection to protect yourself from injury. Use a sharp blade and make shallow cuts, being careful not to cut into the conductors. Work in a well-lit area and take your time. Even with these precautions, using an SE cable stripper is still the safer and more efficient option. Practicing on scrap cable is a good way to get familiar with the SE cable stripper and to fine-tune the depth setting. Use different sizes and types of SE cable to get a feel for how the stripper works on various materials. This will help you to avoid mistakes when working on actual installations. In summary, using an SE cable stripper is the best way to safely and efficiently remove the outer jacket of SE cable. The tool's features, including precision blades, adjustable depth, ergonomic design, and safety features, make it a valuable addition to any electrician's toolkit. By following the steps outlined in this guide, you can ensure that you are using the SE cable stripper correctly and safely. Remember to always prioritize safety when working with electrical cables. Disconnect the power before starting any work, use the correct tools, and inspect your work carefully before energizing the circuit. The NEC, or National Electrical Code, provides guidelines for safe electrical installations. Always follow the NEC guidelines when working with electrical cables and equipment. SE cable, or service entrance cable, is typically used to connect the utility company's service drop to the electrical panel in a building. It is designed to withstand the elements and provide a reliable electrical connection. However, it is important to handle SE cable with care to avoid damaging the insulation or conductors. SE cable is available in several types, including Type SE Style R and Type SE Style U. Type C Style R is used for above-ground installations, while Type SE Style U is used for underground installations. The outer jacket of SE cable is typically made of a weather-resistant material such as polyethylene or polyvinyl chloride, often referred to as PVC. This jacket protects the inner conductors from moisture, sunlight, and other environmental factors. The inner conductors of SE cable are typically made of copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum conductors are often used in larger sizes of SE cable to reduce weight and cost. The size of SE cable is determined by the amperage rating of the service entrance. The NEC provides tables that specify the minimum size of SE cable required for different amperage ratings. It is important to use the correct size of SE cable to ensure that the service entrance can handle the electrical load safely. When installing SE cable, it is important to follow the manufacturer's instructions and the NEC guidelines. The cable should be supported properly and protected from physical damage. The connections to the service drop and the electrical panel should be made securely and insulated properly. After installing SE cable, it is important to test the installation to ensure that it is working properly. Use a multimeter to check the voltage and continuity of the conductors. Look for any signs of shorts or ground faults. If you are not comfortable working with electrical cables, it is best to hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others from injury. An electrician has the training and experience to install SE cable safely and correctly. They can also troubleshoot any problems that may arise. In addition to the SE cable stripper, there are other tools that are commonly used when working with SE cable. These include cable cutters, wire strippers, pliers, and screwdrivers. Cable cutters are used to cut SE cable to the desired length. Wire strippers are used to remove the insulation from the ends of the conductors. Pliers are used to grip and bend the conductors. Screwdrivers are used to tighten the connections to the service drop and the electrical panel. When selecting tools for working with SE cable, it is important to choose high-quality tools that are designed for the specific task. Cheap tools can be dangerous and can damage the cable. It is also important to keep your tools clean and well maintained. A dirty or damaged tool can be less effective and more likely to cause injury. Regularly clean your tools with a wire brush and lubricate them with oil to prevent rust. Store your tools in a dry place to protect them from moisture. By following these tips, you can ensure that your tools are always in good working condition and ready to use. Remember to always prioritize safety when working with electrical cables. Disconnect the power before starting any work, use the correct tools, and inspect your work carefully before energizing the circuit. Electrical work can be dangerous, but by taking the necessary precautions, you can minimize the risk of injury. When working with electricity, it is essential to understand basic electrical principles. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Amperage is the rate of flow of electrical current. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that the voltage in a circuit is equal to the current multiplied by the resistance. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power is the rate at which electrical energy is transferred. It is measured in watts. The power in a circuit is equal to the voltage multiplied by the current. These basic electrical principles are essential for understanding how electrical circuits work and for troubleshooting electrical problems. By understanding these principles, you can safely and effectively work with electricity. Always remember to prioritize safety when working with electrical cables and equipment. The electrical work can be dangerous, but by taking the necessary precautions, you can minimize the risk of injury. And always consult with a qualified electrician if you have any questions or concerns about electrical work.